Okay, here we go. We're just going to start with number 1, and we're going to go through number 20, right? Might take us a few videos to do this in, but we'll see how it goes. All right, here's the first one, -4 cubed. Now watch what you're doing. You're cubing everything in here, right? So you're cubing the negative as well. So it's negative times negative times negative, which is going to give you a negative. Agreed? And then it's 4 cubed. 4 times 4 is 16. 16 times 4 is 64, so it's negative 64. You okay with that? All right, starting off pretty easy. Look at this. Order of operations. So it's 9 plus 4 times 11 plus 25. All right, this is not difficult, but I mean, the arithmetic's easy. You just got to know what order to do things in. That's what they're testing on this problem right here. Just make sure you know how to do things in the right order. A lot of people, like little kids, before they do algebra, they'll probably look at this and say, oh, 9 plus 4 is 13. 13 times 11 is 143. You know, is that what you do? No. You got to do what first? You got to do the multiplication first. Okay, so you have to do that first because it's multiplication, division before addition and subtraction. So you do that first. So it's 9 plus 44 plus, oops. All right, plus 25. Okay, and then you just add this up. What's that? 53, 53, that's 78. Is that the answer? Okay. All right, so far so good, right? Let's look at number 3. This is an evaluate problem. If you don't understand something, stop me. Okay, I'm just going to keep rolling, but you know, if there's something you're not sure about, let me know. So we got negative 6x plus 6y plus 5a. And they tell you, I'll just write it right here, they say if x equals, what do we got? Negative 2, y equals 3, and a equals negative 4. All right, so we got to figure out what this thing is equal to. Now look, we're not solving for x, are we? We're not solving for y, we're not solving for a. We're just trying to figure out what this thing is equal to. I mean, throughout the years on these kind of problems, I've just seen kids just put some crazy stuff down here and they just obviously don't know what's going on. We're not trying to solve for x. We're not trying to get x by itself. We're just trying to take what x is equal to, what y is equal to, what a is equal to, chuck them in to each of those, figure out this is just going to be one number at the end. It's just going to come out to one answer. It's not going to have x in the answer. It's not going to have y or a in the answer. It's just going to be just one single number. Everybody got that? All right, so you got to figure out what to do. This negative 6x, it's negative 6 times x, which is negative 2. Okay, we'll do that in a second. Plus 6 times y, which is 3, plus 5 times a, which is negative 4. Now look, do this step. Don't think you can get away with just doing this in your head because you're going to mess up. Do this step. Actually put it in here so you can see what you're supposed to be doing. If you try to do too much in your head or too much in the calculator, you're just going to get confused. All right, show your steps. That's why I harp all the time on showing your work. Negative 6 times negative 2 is positive 12. That's going to be a plus 18, and that's going to be a minus 20. We good so far? Okay, let's see. 18, it doesn't matter what order. I'll do it like this. 18 minus 20 is negative 2. 12 minus 2 is 10. Is that the answer I gave you? Good. I hope it is. Let's do another one like this. So it's another evaluate problem, but this time they throw absolute value into it. So it's a little bit of a twist. So here we go. We've got the absolute value of 10y minus 10x, and then minus another absolute value of negative 4y. Alright, and they say let x equal 15 and y is equal to 9. Alright, same kind of deal, right? Just plug and chug, stick the stuff in here, but we got to deal with the absolute value, so you got to make sure you do that. Look, don't try to get rid of the absolute value right away. Figure out what's inside of the absolute value first, and at the very end, that's what we're going to do. We'll figure out what the absolute value is. So I'm going to keep the absolute value here. So it's 10 times, watch, 10 times y. Y is 9. And again, I know you could probably do that in your head. and write it down, but I think it's a good idea to write your steps down. So at least if you, like, you know how you do corrections in here, right? You go back and you look at the corrections, like, okay, what did I do wrong? If you just did everything in your head the first time, you'll have no clue where to go back and look to see where you went wrong, okay? So it's minus 10 times x, which is 15. That's all in the absolute value. Minus, another absolute value, negative 4 times y, which is 9, and that's an absolute value. All right, let's just do this. Let's kind of slide this stuff over. Is that all right? Just so we have some room over here to work. So let's kind of push this up here. All right, let's see what we get. We still have an absolute value. Let's do the stuff in here. 10 times 9 is 90 minus 150. That's in the absolute value. Minus another absolute value. Let's do what's inside the absolute value. Negative 4 times 9. What's negative 4 times 9? It's negative 36. Okay, I kept it in the absolute value. Again, I'm not trying to go ahead of myself. I'm trying to do little steps at a time. 90, keep this in absolute value. 90 minus 150 is what? Negative 60, but that's in absolute value, isn't it? Minus another absolute. We can actually do this now. Now you just have one number inside that absolute value, don't you? It's minus a 36, right? Some people will look at this and say, oh yeah, minus minus. You know how you do that? You know, negative negative, but it's not the same thing now, is it? Because this is in an absolute value. So it's minus from here, so that goes right there. But it's minus what? Just a 36. Okay? So it's not plus 36, is it? And a lot of people look at this. I've seen this many, many times. People will say, oh, minus minus plus 36. No. This is in an absolute value. The whole reason the absolute value is there is so we make that thing positive. All right, let's do this. The absolute value of negative 60 is just positive 60 minus 36. And let's see, what's that? 24, is that right? And that's your answer right there. Make sense? Okay, I went little steps at a time. Okay, it doesn't take long just to write a couple extra steps down. It's worth it to get the problem right, I think. Don't try to do too much in your head on these. All right, let's move on. Okay, let's go to number 5. It says add the polynomials. So it's 9a to the 5th plus 5a to the 4th. I guess I could just pause this thing, right, while I write the problem. Maybe I'll do that the next time. Plus 7a to the 5th minus 3a to the 4th. It's supposed to be a 4 right there. Okay, let's take a look. Now, you got parentheses here. When you see parentheses, a lot of people, well, not a lot, I mean, I've seen some people look at this and say, oh, parentheses, that's multiplication. But does parentheses always mean multiplication? No, because look what's going on here. It's addition, isn't it? You got a plus in between these parentheses, so you're adding. Now, really, in this particular situation, do these parentheses even do anything for us? They don't do anything for us at all. All right, because if this was a minus right here, then you would need the parentheses here, wouldn't you? All right, because then you would have to distribute. But if I distribute a plus, that doesn't change the value of it at all, does it? So what I'm going to do is I'm going to write it. I'll just rewrite everything without the parentheses. Now, if I were you, on the test, you've already got this thing written out, don't you, on the test? So I would just write that as my first step. That's what I would write down as my first step, okay, and not put the parentheses there. Now, we're adding. We add like terms. You got to find the things that are like terms. Again, this is another thing that gets a little confusing for some people because they're not sure about adding like terms. This is a to the 5th, this is a to the 4th, a to the 5th, a to the 4th. So we can only take the terms that are the same. So even though the numbers out in front are different, that doesn't make any difference. Okay, the coefficients, the numbers out in front, they can be different. Right? It's these terms, the variable and the exponents. They have to be exactly the same. So which ones are your like terms? The a to the 5th and what? This 7a to the 5th. You got it? So those are the ones, I'll circle them. Those are the ones that we can add together. Now, when you add them together, you just add the coefficients and you keep the term the same. You hear what I just said? Okay, I'm not just blowing off a lot of words, okay, for them to bounce off your head. Watch. I add the coefficients and keep the variables or the terms the same. So when I add the coefficients, that's the number out in front. 9 plus 7 is what? 16. And I keep the term the same. So what's my term? It's a to the 5th. It's like saying this. It's like 9 apples plus 7 apples is what? 16 apples, right? It's the same kind of deal. 9 of these things plus 7 of these things equals 16 of these things. Don't add the exponents. All right? When's the only time that you add the exponents? When it's multiplication. That's right. I've seen it many, many times that people try to add the exponents here. Don't do it. You're only adding like terms. You keep the term the same. All right, enough of that. I'll put the next terms in a box just to separate them so you see them different. Now those are like terms as well, aren't they? A to the fourth and a to the fourth. So let's add those together. I got a positive 5, I got a minus 3, so what do I got all together? I got a positive 2, so I put a plus there. If it comes out positive, I put plus. If it comes out negative, I put a minus. So it's 2 what? A to the fourth. Can I add those together? No, I can't because they're unlike terms. They're not the same term. Even though they got a bunch of A's in both of them, this has 4, this has 5, that's enough to make them different terms. They are not like terms. It's all you can do, and you just leave it just like that. All right? It's a simple problem, but there's a lot of mistakes that could be made that people get confused over other rules compared to this rule right here. And just make sure you separate those rules. All right, look at this problem. This is very similar to what I said could have been up here. Remember I said this, if this is a plus, it doesn't change anything in there, don't even need the parentheses at all. But I said if it was a minus, what would you have to do with that minus? You'd have to do what to it? Give me one word, quick. Distribute it through, right? All right, now this problem, we do have a minus, don't we? All right, so we're testing you on both of these. So really, this first parentheses, is there anything being multiplied by this first parentheses? No. So I don't really need anything in that first parentheses. So I'm just going to rewrite it the way it is, but I do need to change this. There's a minus right here, so you're subtracting everything in here, or you're taking the opposite sign of everything in here. So I distribute that negative through here. Does that make sense? So basically it just changes the sign. So now it's minus 3n squared, and it's minus 9n to the fifth, and it's what? Plus 2. That's very important that you do that. All right, that's the key step. That parentheses definitely was important on this problem, right? That second parentheses, because you had to distribute it through. Now let's go through the whole thing and find some like terms. I always like to start from the highest power first, all the way down. We call that descending order. You don't have to. It doesn't matter what order you put them in. I just kind of like to do it that way. N to the fifth. Do you see any other n to the fifths? Right here. So let's do those. 5 minus 9 is negative 4. What's my term? N to the fifth. I'm done with that, so I like to cross them out when I'm done. What's the next power? N squared. So do I have any other n squareds? Sure, right here. So I got 7, and I got a minus 3. 7 minus 3 is plus 4. What's my term? N squared. So I'm done with that. Now, I just have regular numbers left over, constants. Negative 18 plus 2 is negative 16. We put a minus 16. You can't add anything else up, and that's it. You just leave it, just like that. All right? Adding like terms. Make sure you distribute the negative through here, and then you add up all the like terms. It doesn't matter what order you put it in, but this is kind of the nicest order to put it in if you wanted, to put it in a certain order. All right, so that's addition. What do you think's coming next? We added polynomials. What do you think we're going to do next? Multiply. That's right. So let's do some multiplication. All right, let's take a look at this. This is now multiplication. Look, there's no plus or minus in between these two, are there? All right, so that means this thing right here is being multiplied by everything in the parentheses. So what we're going to do is distribute. We're going to take this negative 2ax cubed, that's a 3 right there, negative 2ax cubed. We're going to multiply it by the first term, then the second term, and then the third term. And then if we can, look to see if you can add any like terms. I don't know if you can on this one or not, but always look to see if you can. So let's do this real quick. I've got a minute left. Negative 2 times 10 is negative 20. Then a times a is a squared. This is the rule where you multiply or you add the exponents. X cubed times x to the fifth is x to the what? 8th. Good. Now we do the next one. Negative 2 times positive 6 is negative, so we put a minus. 12. There's no a here, and that's going to be x to the 7th. All right. Then what do we got? I got another minus, right? 22. Multiply the a's, a squared, and you got a x cubed. Any like terms here? Nope. So you just circle it, and you're done. We good? All right. Let's go to the next video. We'll continue.